Let's talk about the average rate of change of a function between 2 points. First of all, in order to talk about the average rate of change, you really need 3 pieces of information. You need to know the function that you're investigating, and then you need to know the 2 x values that will give you the 2 points that you use in your calculation. So here I said x1 equals a and x2 equals b, and that's the common notation for the average rate of change. So the formula for the average rate of change is actually very simple. It's just f of b minus f of a over b minus a, right? So you take the y-coordinate of one of your points and subtract the y-coordinate of the other and divide it by the x-coordinate of the first point minus the x-coordinate of the other point. So let's take a look at what this means visually. If I have a function, say f of x, looks like this, and then I have my 2 points, x1 equals a, and here x2 equals b. So these are the x-coordinates of what are going to be my points. My points are the actual points that are on the graph of the function here and here. So these are the two points have coordinates a, f of a, and b, f of b. Okay. So it's clear to see that these 2 points are connected by this blue function. But we could also connect these 2 points using a straight line, right, that just goes through each of those points. So let's make sure it actually goes through that point, a comma f of a. Now, if I were to say, I've got a straight line that goes through 2 points, and I know the coordinates of those 2 points, then I could ask you to calculate the slope of this line. So go ahead, find out on your own paper, determine what the formula for the slope of this green line should be, given the 2 coordinate points b, f of b, and a, f of a. You can hit pause on the video, work it out for yourself, try to remember, look it up if you need to, and then we'll come back and check your work. So go ahead and hit pause now. Okay, hopefully you've hit pause and done the work on your own, so let's confirm. So the slope of a line based on 2 points is just the y-coordinate of the second point minus the y-coordinate of the first point divided by the x-coordinate of the second point minus the x-coordinate of the first point. But notice this formula for the slope of this straight green line is the exact same as the formula for the average rate of change. So visually, the average rate of change is just the slope of the line that connects the point a comma f of a to the point b comma f of b. All right? The average rate of change, thinking about it visually, is the slope of this green line. Okay. Numerically, it's also pretty easy to figure out what the average rate of change is. So let's take a look at a numerical example. So again, we need 3 pieces of information. We need f of x, and so let's say f of x is 2x squared. And we need the 2 points. So let's let x1, which is a, let's let that be 1. And to make it real clear, rather than writing x1, I'll write a. A equals 1, and let's let b equal 3. These are the 3 pieces of information: the functional form, the first point, the first x-coordinate, and the second x-coordinate. So then the average rate of change is simply f of b minus f of a over b minus a, which is, let's see, 2 times b squared, so 2 times 3 squared, minus 2 times a squared, so 2 times 1 squared, all over b minus a, so 3 minus 1. Now if I work that out, that first number becomes an 18, the second number is 2, and I divide that difference by 2, and so I get 16 over 2, or 8. So the average rate of change between the point that has an x-coordinate of 1 and the point that has an x-coordinate of 3 is 8. And we can actually investigate this visually again. So I'm just going to draw the right side of this function, 2x squared. And the scale's not going to be totally accurate because I want to be able to demonstrate this straight line pretty easily. So if a equals 1, then f of a should equal 2. And if b equals 3, then f of b should equal, well, 2 times 3 squared, so it should equal 18. So if I draw the coordinate points, a f of a and b f of b, I can start asking some questions. For example, what's the total change in the y-coordinate? Well, it goes from 2 to 18, so it's got a total change of 16. But what's the total change in the x-coordinates? Well, it goes from 1 to 3, so it's got a total change of 2. So over 2 units goes, when the function goes over by 2 units, it goes up by 16. So on average, if it goes over 1 unit, it should go up by 8 units. Right, and then it goes over another unit, and it goes up by 8 more units. And if we see, and we take this straight line, and we connect these dots, and we see the slope of that straight line has a slope of exactly 8. Right? That's our average rate of change. Notice the function itself is changing more slowly here than it is there. So the rate of change of this function is not constant. But the average rate of change says, well, on average, whenever we move over 1 unit, we must move up 8 units. And then we move over another unit, and we move up, on average, 8 units. So that's how you find the average rate of change. It's really as simple as finding the slope of the line connecting these 2 points. And when you do it numerically, it's really just having the correct functional form, plugging in the correct numbers, and then doing the arithmetic correctly. So that's all for the intuition of average rate of change. The next video will talk about units on the average rate of change.